This is going to be a quick video to show you how to factor with a greatest common factor. Of course, watching the video is not required. If you feel like you already know how to do the assignment without this, then go ahead and go for it. The assignment that was due today, I asked you to find the GCF of something like 18 and 24. And some of you know right away the answer to that is 6. But I want to show you a review of factor tree and then how we're going to actually factor using the greatest common factor. 18 is 6 times 3. You could start with 9 times 2. It doesn't matter. So I like to circle my prime numbers as I go so I don't lose any of them. 6 is 3 times 2. So 18 is 2 times 3 squared. 24, you can start with 2 and 24, 8 and 3, 4 and 6, 2 and 12, it doesn't matter. I'm going to start with 4 and 6. 4 is 2 times 2, and 6 is 2 times 3. So 24 factors as 2 cubed times 3. So the GCF between these two, what's the highest numbers that they have in common? Well, there's a 2 to the first and a 2 cubed. What they have in common is a 2 to the first. We have 3 squared and 3 to the first. The highest that they have in common is 3 to the first, which is 6. You do not need to show any of that. Just going to try and review it with you. So let's throw some variables in there. So let's say I give you 18x cubed y squared, and I give you 24x squared y cubed. Okay, so we know from above that the greatest common factor between 18 and 24 is 6. I looked at x cubed and x squared. The highest that they have in common are 2 of them. 2x, x and an x, and an xxx. The most they have in common is 2 of them, which is x squared. And for the y's, same thing. The highest that they have in common is a y squared. So that would be the GCF. Okay, so I'm going to take this a step further, and I'm going to ask you to factor the binomial. So here's what I'm going to do. I want you to factor 18x cubed y squared plus 24x squared y cubed. Okay, well, you always start with the GCF. That always comes first. There's no exception to that rule in all of factoring. Their GCF is 6x squared y squared. Okay, I'm going to go back up to 18. 18 was here. Well, if I take out 6, you know what? My apologies. I'm going to rewrite that down here. 18 was 2 times 3 times 3, and 24 was 2 times 2 times 2 times 3. Okay. So for 18, if I take out 6, which is 2 times 3, I'm left with 3. I'll get to the variables in a minute. And for 24, we said the GCF was 6. Well, if I take out 6, 2 times 3, I'm left with 4. And notice 6 times 3 is 18. 6 times 4 is 24. I'm going to put a plus sign there. And let's look at the variables. If I take x squared out, I'm left with an x. If I take y squared out, there's no more y's left. Let's go over to 24x squared y cubed. If I take x squared out, it's all gone. If I take y squared out of y cubed, I'm left with a single y. And this is how you factor with a GCF. Everything starts with that greatest common factor. So let's do another one. So I'll do a couple more again. The video is optional. Let's look at something like 15ab squared plus 10b to the fourth. First thing you need to find is that GCF. 15 is 5 times 3. 10 is 5 times 2. The most they have in common is a 5. There's no A's here. So the most they have in common is nothing. There's no A's associated with the 10. So there are no A's for your GCF. B squared, b to the fourth. The most they have in common is a b squared. There's your GCF. If I take 5b squared out of 15ab squared, I take 5 out, I'm left with 3. If I take b squared out, I'm left with a. If I take 5 out of the 10, I'm left with 2. If I take b squared out of b to the fourth, I'm left with b squared. If it helps you, you might want to consider writing out like variable, variable, variable. What do I mean by that? It could take a while, but it will help you get used to the pattern. Let's say I have, let's do 18 x squared y z cubed minus, how about 15 x y z squared. So this is what I mean by writing it all out. 18 we already did. We already did 18 from the previous problem. It was 2 times 3 squared. So I'm going to write this as 2 times 3 times 3. X squared is xx. Y. Z cubed is z, z, z. I don't recommend always doing this. I only recommend it till you get used to it. 15 is 5 times 3, 3 times 5. Who cares? X, Y, Z, Z. Okay, how many 2's? They don't have any 2's in common. How many 3's? They have 1 3 in common. How many 5's? They don't have any 5's in common. So my GCF between 18 and 15 is 3. We've got 2 x's and 1 x, so they have 1 x in common. Y, y, cool, they have a y in common. Z, 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 they have 2 z's in common, and I'm going to write that as z squared. Okay, let's start with the 18. If you take 3 out of the 18, you're left with 2 times 3, which is 6. If you take x out, I'm going to cross one of those out, you're left with 1. If you take a y out, no more y's are left. If you take z squared out, 1, 2, you're left with a z. $15. If I take 3 out, I'm left with 5. If I take x out, no more x's. If I take y out, no more y's. If I take out z squared, no more z's. That's it. That's the basic of finding a GCF.